So hello everyone, this is the probability and stochastic homework 7 question 8. And in this question, it has two different parts. And in the first part, it requires us to find the mean of xt. So firstly, we can calculate the ax, the mean of ex. So we know that. So as we know that x is belong to the Poisson distribution, so we can firstly we can list the formula of the ax. So the formula ax is equal to this part, sigma k equals to 0 to infinity k times e to the power of minus lambda times lambda to the time of k and divided by k part. This is the Poisson distribution. So we can firstly we can differentiate by the part firstly, as we know that the Poisson distribution is belong to this part, so through the differentiation, we know that we can for the following processing, we know that the k equals to 0 to the infinity k times lambda to the power of k minus 1 divided by k equals to e to the lambda to the power of lambda. So we can finally obtain the consequence as this function. So this function is equal to the mean of e. So the ax is equal to lambda. So as from the questions above, we know that we can compare to the two parts of this formula. We know that if xt replace x, the consequence we need to times lambda t. So the final consequence of xt of the mean is lambda t. And for the second part, it requires us to calculate the autocorrelation of so we can list the formula in the textbook as this part, and from the theorem to about the question, we know that S2T2 minus S1T1 and xt4 minus xt3 are independent. So then we can assume T2 larger than T1. So then we can simplify xt1, xt2. We can list the function like this part to help us to calculate the following function. So it equals to xt1 times xt2 minus xt1 plus xt1. So we can then simplify this function and obtain the consequence as this part. And from the theorem 2, we mentioned about, we know that xt1 and xt2 minus xt1, these two parts are independent. So we can divide this part, these two parts, for the mean, and using the first part, we can differentiate the two parts again, and so we can easily obtain the formula the mean of x squared is equal to 1 plus lambda times lambda. So it's also easy to know that the xt we can replace lambda t into lambda. So we can get that the mean of xt squared is equal to this function. So finally, we can take the parameters we obtained above into the autocorrelation. So we get this part, this line, and then we can take the consequence into this function, and we know that we can get the last line in the paper, and through the following simplification, we can finally get this part. Get the final consequence, lambda times t1 plus lambda t times t1 times t2. So as we know that we assume t2 larger than t1. So if t1 less than t2, so this part t1 is it should be t2. So the final consequence, so we know that when t1 and t2 are random, the autocorrelation is equal to the minimum of t1, t2 for this part. So this is the final part, final consequence. That's all.